Hello students, today we will learn buoyant force. What is buoyant force? Every fluid exerts an upward force on a body immersed in it, which is called buoyant force. Let's understand the derivation of the buoyant force. Here we are taking a container which is filled by a fluid of density d. The density of fluid, that is d. You know the gravitational acceleration, that is g. And we put one cylindrical object in this container which have height of h. We are taking height h, and I am taking that the bottom of the container, that is at the depth of h1. Okay, and the top of the container, that is at the depth of h2, right? And we are taking pressure exerted by fluid on the cylindrical object. If we consider a pressure exerted by fluid on the above and below surface, which is pressure P2, and from below, that is pressure P1. As you can see that from the formula of pressure exerted by fluid, we can say that the pressure exerted at the bottom P1, that is dgh, density of fluid, gravitational acceleration, and height, that is h1, same as P2, that is equal to dgh2. You can see that here h1, that is greater than h2, so we will write h1 is greater than h2, so p1 is greater than p2. So the net pressure or net force exerted is in upward direction. So the difference of p1 minus p2, that is in the direction, that is upward direction, that will be in upward direction. And we need to find the upward force. We need to find upward force, and we called it buoyant force. So buoyant force, that is equal to pressure difference into area. We know that pressure is equal to force by area, so force will be pressure into area. And we will put the values. What is P1? P1 is dgh1, dgh1 minus dgh2 into area. We will take d and g common, that is h1 minus h2 into area. You can see from the figure here h1 minus h2 is h1 minus h2 is h, which is height of container. So we will take density, the gravitational acceleration, into a into h. As we know that area into height, that will give you volume, dgv, that will give you the volume of this cylindrical shape object. Okay, and you can say that the volume of this cylindrical object, that is equal to volume of fluid displaced, that is equal to volume of fluid displaced. Okay, so we can say that volume is that of volume of fluid displaced. The formula of the buoyant force, that is density of fluid, gravitational acceleration, and volume of fluid displaced. This is the buoyant force formula. I hope student you can understand this buoyant force formula. So please remember these two formula: the pressure exerted by fluid at height s, that is dgh, and the buoyant force exerted by fluid when object is immersed in it, that is density of fluid into gravitational acceleration and volume of fluid displaced. Thank you, students.